Hello everyone, welcome to video lectures on subject fluid mechanics. In this session, we are going to discuss unit number 1, Introduction to Fluid Mechanics. Here, we are concentrating on problems on Newton's law of viscosity. So those who have not observed my video on Newton's law of viscosity must watch that video before attending this problem session, because all the problems are based on Newton's law of viscosity. So according to Newton's law of viscosity, shear stress is directly proportional to the velocity gradient. So I will show you here. According to the Newton's law of viscosity, tau T is equal to mu into du upon dy, where tau is known as shear stress, mu is the dynamic viscosity, and du by dy is the velocity gradient, where du is change in velocity and dy is the difference between the layers. Okay, so based on this formula, we are going to solve the problems in this video session. So now let's read the problem number 1. A plate of 0.025 mm distance from a fixed plate. So in this problem you can see the distance between the plate is given, that is dy. In this formula I have explained where dy is the difference between two layers or plates. This is the difference in the velocity, this is viscosity, and this is shear stress. So distance between the two plate, here dy is given as 0.025 mm. It moves with a velocity of 60 centimeter per second, but we know that velocity is represented in meter per second, so we have to convert this centimeter into meter, that is 10 raised to minus 2, so it will be 0.6 meter per second, and requires a force of 2 Newton per unit area. We know that force per unit area is nothing but it is stress, okay, shear stress, that is 2 Newton per meter square to maintain this speed. What is speed? 0.6 meter per second. Now we have to determine the fluid viscosity between the plate, that is mu. I told you the formula here, tau is given, du is given, dy is given. We have to calculate this mu. Now we know that I have told you tau is equal to mu into du by dy. Now let's see one by one. Du, that is change in the velocity. What is the velocity? 0.6, and original velocity is always 0, or the velocity of this fixed plate. Fixed plate means its velocity is always 0, and this upper plate is moving plate, so its velocity is 0.6. So 0.6 minus 0 is 0.6. Now distance between the plates is directly given here, 0.025. Then we can put the value of tau, that is 2 Newton per meter square, in is equal to mu into this du 0.6 divided by this dy, and after putting these values you will get the answer of mu, that is 8.33 into 10 raised to 5 Newton per meter square. But this is SI system. If suppose you want to get the answer in poise, you have to multiply by 10. Okay, this is not needed, but in case of examination, if they ask you the answer in poise, just multiply by 10 to this answer, you will get the answer in poise. So this is simple formula. Only based on this simple formula you can calculate the problem very easily. This is the Newton's law of viscosity. Now we will move towards the second problem. A flat plate of area 1.5 into 10 raised to 6 mm square, but our unit is meter square, so we have to multiply by 10 raised to minus 6. So area of plate is calculated as 1.5 meter square. As this is a millimeter, we have to convert into meters. Okay, so this here again there are two plates. This is a moving plate, this is fixed plate. These are separated by distance dy, and mu is the viscosity between the plates. So it is pulled with a velocity of 0.4 meter square. So this plate, upper plate, is moving with a velocity of 0.4 meter per second, and relative to the another plate which is separated by a distance of 0.15. So this 0.15 is nothing but dy. So distance between the plates is given as 0.15 mm. Again millimeter has to be converted into meter, that is 10 raised to minus 3. So this is the distance between the plate. Now we have to find out the force and power required to maintain this bed. So we have to calculate the force and power. If fluid separating them where viscosity is 1 poise. So see, in this problem viscosity is directly given, but we have to calculate the force and power. Again the same formula we have to consider. Tau is equal to mu into du upon dy. Here viscosity is given in the poise. Okay, we have to convert into Newton per second. In the last problem, to convert Newton second into meter we have multiplied by 10. But if you want to convert the poise into Newton per second meter square, we have to divide by 10. So keep in mind that thing. So 1 poise is equal to 1 upon 10 Newton second per meter square. This is very important conversion from this to this, poise to SI system. So again I told you that we have to use the same relation. Tau is equal to mu into du by dy, and here we have the value of, we have to calculate the value of tau, where mu is equal to 1 upon 10 we have substituted, into du is the change in the velocity, that is 0.4 meter per second, divided by where dy is the difference, that is 0.15 into 10 raised to minus 3 I have put here, and you will get the answer. Tau is equal to 266 Newton per meter square. Now you want to calculate the force. The force always in a Newton, but this is Newton per meter square. So here the area of plate is given. See here 1.5 meter square. So you can calculate the force. If you know the stress, if you know the area, then you can calculate the force. Then you know that shear stress from the formula, you know that stress is equal to force upon area. So force is equal to, if you transfer this area to left side, force is equal to tau into area, where tau is equal to 266.6 and area is 1.5. You will get a force in Newton. So your answer is 400 Newton. This is your second answer. And third question is power required. If you want to calculate the power, you have two values, that is force and velocity. So power is equal to force into velocity, where force is 400 Newton and your velocity is 0.4 meter per second. So you will get a power, that is this power is required to move this plate in this direction is 160 watt. Power always represented in the form of watt. So F into U is equal to your power. This is the answer of your second question. Now we will move to the third question. There are two horizontal plate. Again the concept is same. This is a fixed plate, this is moving plate. Upper plate is moving with a velocity du. dy is the difference between these two plates, and mu is the coefficient of viscosity. Now these two plates are separated by distance 1.25 centimeter. So we know that distance is in centimeter, convert into meters. So multiply by 10 raised to minus 3. The space between them is filled with oil. See, the dotted line shows that the different distance between these two plates is filled with the help of oil. Here viscosity given. Again I told you that if you want to convert the viscosity poise into Newton second per meter square, we have to divide by 10. So convert this poise into divide by 10. So 14 divided by 10 is your Newton second per meter square. This is your viscosity. Now we have to calculate the shear stress. We know the formula, tau is equal to mu into du by dy. So in oil, if upper plate is moving with a velocity of 2.5 meter per second. So lower plate is fixed, upper plate is moving with a velocity of 2.5 meter per second. So again same formula, tau is equal to mu into du by dy. So now tau we have to calculate. You know the value of mu here, you know the value of u, and you know the value of y. You can directly put here tau is equal to this value. If you substitute, you will get the answer 280, and shear stress is always in Newton per meter square. So this is the answer of third question. Now we will go to the problem number 4. Now in this problem we have to calculate the kinematic viscosity. I taught you that kinematic viscosity is represented by nu. This is a Greek or Latin symbol nu. So we have to calculate the dynamic viscosity of an oil having density of 981 kg per meter cube. So density is represented by rho, 981 kg per meter cube. The shear stress at a point is given in Newton per meter square. So shear stress tau is equal to 0.2452 Newton per meter square and velocity gradient is 0.2 per second. It means in this problem the value of du by dy is given. In the previous problems du is separately given and dy is separately given. But in this problem the ratio is directly given 0.2 per second. So we have to calculate here nu is kinematic viscosity. Now to calculate the kinematic viscosity nu, we need the value of mu. Then we have to first of all calculate mu. So let's see, from tau is equal to mu into du by dy. From this formula you can calculate the value of mu, that is 1.226 Newton per meter square. This is the value of mu, and we know that nu is equal to mu upon rho. This formula I have given in the theory part. So I am suggesting you that first of all you see my previous theory lectures, then only you will understand this problematic part. So you can calculate nu is equal to mu. Just now you have calculated 1.226 divided by density 981. So if you calculate this, you will get your answer in 0.215 10 raised to 2 meter per second. This is the unit of nu. This is again I have given in the theory. But suppose in examination, if the question is asked in Stokes, then you have to do this convergence. You have to multiply by 10 raised to 4. So your answer get converted from meter square to centimeter square per second, and this is nothing but your answer. Centimeter square per second is nothing but Stokes. Okay. So there is a conversion from meter square to centimeter square, and this is the answer in Stokes. Now last problem we are going to discuss is determine the viscosity of a liquid. Again we have to calculate here viscosity mu. If kinematic viscosity is 6 Stokes, I told you that kinematic viscosity is always in meter square per second, but in this problem it is given in Stokes. Stokes means centimeter square per second. We have to convert this into meter square per second. So multiply by 10 raised to minus 4. So no, mu is equal to 6 into 10 raised to minus 4 meter square per second. Specific gravity is 1.9. Specific gravity is represented by S. Specific gravity is represented by S. So we have to calculate the answer viscosity. Then let's solve the problem. We know that specific gravity of a liquid is the density of a liquid upon density of water. Again I repeat, this formula I have given in the theory part. Please refer my theory part first to understand this problem. So specific gravity of a liquid is 1.9. So I have written over here. Then density of liquid we have to calculate, divided by density of water, it is always 1000. So from this formula if you multiply by 1.9 into 1000, you will get density of liquid is equal to 1900 kg per meter cube. So what we have to calculate? We have to calculate the viscosity. If you know the nu, how to calculate viscosity? We have the relationship nu is equal to mu upon rho. This formula we have used in previous problem also. So here nu is equal to 6 into 10 raised to minus 4 we have kept here. Density we have just now calculated 1900. So do the multiplication of these two, you will get the answer of viscosity, that is 11.40 poise, or directly you will get answer in 1.14 Newton second per meter square. Again I told you that if you want to convert Newton second per meter square into poise, multiply by 10. So your answer will be in the poise. So all these problems are directly based on formulas. There is no specific logic or any procedure to solve the problem. So I must suggest you that you have to practice the formulas, you have to mug up the formulas, then only you can solve the problems. Okay? Thank you.